Work example 5, simple single component circuits. A simple circuit is shown in diagram 22. The battery is 24 volts, so our VS is 24 volts, and the current is 1.5 amps. And we're asked to calculate each of the following part A, B, C. The resistance of the circuit, the power of the resistor, and the energy consumed after 8 minutes of running. So for part A here, we're asked to calculate our resistance. Well, V, I, and R, the equation we have is V equals IR, Ohm's law. Now, of course, we're looking for the resistance, and we have I and V. So what we need to do is to rearrange this. Now, when it comes to rearranging, there's a couple ways you can do it. You can remember this version of it and just simply rearrange it. So bring the I underneath. So R is V upon I. But a common and a popular method with students is to remember the Ohm's law triangle. So any equation where you've got three forms in this, where it's something equals something times something, can be arranged into a triangle like this. And the way the triangle works, just to explain it briefly, is V equals I times R. And if you're looking for one of the other terms, say I, then you just cover up the I and it's V over R. If you're looking for R, you cover up R and it's V over I. And if you're looking for V, you cover up V and it's I times R. So a nice little introductory hack there, just to help you figure out which is which. So I'm looking for R, so we'll use a triangle, cover up the R, and with V over I. So R is V over I. Go ahead, substitute our values in of 24 over 1.5, and we end up getting 16 ohms. For part B, the power, well, again, we've got P. We've actually got R this time, we've got I and V, so there's a couple of different ones we could use. We could use P equals IV, or we could use P equals I squared R. Both these will give the same, so let's just run through both just to see what that's like. So PIV would be P 1.5 times 24, and that would give us 36 watts. Or we could say that P equals 1.5 squared times the resistance that we just worked out of 16, which again would give us 36 watts. Then part C, energy consumed after 8 minutes of running. Well, energy is equal to power times time. And again, you can use your little triangle here, E equals PT, to help remember. So in this case, we're looking for energy. So we'll cover that and we've got P times T. So in this case, energy is going to be our power of 36 multiplied by our time. Now, the time we're given is 8 hours, but of course we need to convert that 8 hours into 8 hours worth of seconds. So every hour has 60 minutes, and every minute has 60 seconds. So we need to convert that, and that is going to give us 1,036,800 joules, which equals 1.037 megajoules. Question 2. A simple circuit has a resistance of 100 ohms and a current of 2.1 amps. Determine each of the following: the voltage of the battery, the power of the resistor, and how long the circuit must be run to consume 1000 joules. First thing we have to find out is the voltage of the battery. So again, we've got I and R, or R and I here. So V equals IR. So we can go ahead and use our Ohm's law again. So V equals IR. I is 2.1 times our resistance of 100. And that's going to give us 210 volts over our resistor here, or the voltage of the battery. They're then asked for B, the power consumed, or the power of the resistor. And again, we've got IR and V. So we can use either P equals IV or P equals I squared R. Let's just go with P equals IV. So in this case, we have 2.1 times our newly found voltage of 210, which gives us a power of 441 watts. And finally, for part C, we're asked to work out the time it's been running if it's consumed 1000 joules worth or converted 1000 joules worth of energy. So we have our E equals PT formula. We're looking for T, so that means we need to rearrange this, bring the P underneath, and we've got T is energy divided by power. So in this case, our energy is going to be 1000, and our power is going to be what we calculated. So 411, and that gives us 2.27 seconds of operation. So the circuit needs to run for 2.27 seconds in order to consume 1000 joules worth of energy. Worked example 5, question 3. A simple circuit has a resistance of 1.2 kilo ohms and a supply voltage of 12.5 volts. Determine each of the following: the supply current of the circuit, the charge that has moved through the circuit after 5 minutes, and the power of the resistor. Again, we're going to be using a rearrangement of Ohm's law. So VIR, we're looking for I, so it's going to be covering up the I is V over R. So I is V upon R, or 12.5 divided by 1200, which in this case equals 10.4 milliamps. Now, just to show you that on the calculator, because it can be a bit confusing, if we have 12.5 divided by 1200, we get this. Remember, some calculators either have a function buried in one of the menus, or you can press S to D button to convert that, and you'll see that we get this very, very small number, 0.0104. We don't generally want to present it like this. We want to present it in engineering notation. So we want to find the ENG, and again, on some calculators it might be buried in a menu. We have to search through it and convert it into engineering notation. But you can see here we've got 10.416 times 10 to the minus 3. So that becomes 10.41 times 10 to the minus 3 amps. But times 10 to the minus 3 is milli, so we can present it as 10.4 milliamps. Part B here was the amount of charge that's moved through the circuit after 5 minutes operation. Well, Q is based on the current and how long it's been running for. So Q equals IT. So in this case, our current we've just established is 10.4, or 10.4 times 10 to the minus 3, multiplied by our time. Now we have to convert our minutes into seconds here, so that's going to be 5 minutes times 60 to give us the number of seconds. So 10.4 times 10 to the minus 3 times 5 times 60 gives us 3.13 coulombs worth of charge. Part C, calculate the power. P equals IV. 10.4 times 10 to the minus 3, multiplied by our voltage, which was 12.5 volts. So in this case, we get 0.13 watts of power. Worked example 5, question 4. A simple circuit has a battery of 6 volts and after 4 minutes has consumed 200 joules of energy. Question A, sketch a diagram of the circuit. Part B, determine the power of the circuit. C, the currents in the circuit, and the circuit resistance for part D. Well, for our circuit diagram here, I've gone ahead and drawn a resistor and our battery. We've got a 6 volt supply. The resistor, or the component, we're not really told it's a resistor, but we can assume it is. The component's consumed 200 joules in 6 minutes. For part B, we need to work out the power consumed, and for that we're going to use power is equal to energy over time, and that gives us 200 over a time of 4 minutes, 4 times 60 to convert it into seconds, and that gives us a total power of 0.83 watts of power. Question C is to work out the supply current, or the circuit current here, and for that we're going to use I as power over voltage, which we've just calculated the power of 0.83 watts, and so we can divide that by our voltage of 6, and that gives us a current of 139 milliamps. In part D, we are asked to work out the circuit resistance, and for that I'm going to use Ohm's law with R is equal to V over I, and in this case my voltage of 6 is then divided by my current that I've just calculated of 139 times 10 to the minus 3, which gives me a resistance of 43.2 ohms. Okay, question 5. The supply current is 600 milliamps, so we're told straight off the bat IS is 600 milliamps, which is 600 times 10 to the minus 3. And the circuit consumes 5.5 kilojoules of energy in 30 seconds. And from there, we're then asked to calculate the power of the circuit, determine the supply voltage, and finally the resistance of the resistor. So again, we've got P, we've got E, we've got T, and we've got I. So for me, I think we're going to use E equals PT, rearrange, and this gives us power is energy over time. Now notice this time I didn't use the triangle, I've just rearranged, I've just brought that T underneath here, dividing the E by the T to give me E over T. So our power is going to be equal to the amount of energy, so that's 5,500 joules, divided by time, 30 seconds. I've already converted the 5.5 kilojoules into 5,500, I did that up here, and the time is in 30 seconds already, so no need to convert that to anything. So 5,500 divided by 30, and we end up getting 183.3 watts of power. Part B asks us for the voltage, and in this case, the most frequent one we would normally go to is V equals IR. We don't have R, so we need to look and see if there's a different way we can work out our voltage here. And for that, we're going to be using P equals IV, because we're looking for the voltage, we've got the current, and we've just calculated the power. So we can rearrange this, again via the triangle if you like, where V equals P over I, and in this case, power, we've just calculated is 183.3, divided by our current, which we're given right at the start, is 600 times 10 to the minus 3 amps. And when we do that, we get 305.6 volts. Lastly, we're looking for the resistance, and for that one, V equals IR, we can rearrange to be R is V over I, and we can go ahead and substitute our values in. 305.6 divided by our current of 600 times 10 to the minus 3. And when we plug that into the calculator and hit equals, we get 509.3 ohms of resistance.